I have been world building for quite a while now, and I've written enough articles that it is very difficult for anyone that isn't me to get any sort of foothold in my world. If I want to be able to clearly communicate my world to others, I need to understand my world, the path through it, and the detours that most readers will get lost in. Understanding my world more fully will not only help my potential readers, but also myself when I'm writing, because I will know where to put my efforts, where to make a more streamlined story, and where to increase complexity. But with so many articles, it is difficult to keep everything straight. Let's see how some code can help. As a preface, to actually write all the code we will need for this process, I'll be working in Python. I'm using PyCharm for my IDE, but any IDE will work. Extracting the information we will need will not be too difficult if we know the format in which the articles are stored. In my case, I am using Worldbuilding and have exported my world. This gives me a JSON file that defines the article in question. If you want more information about this, I plan on making a video detailing how to export Worldbuilding worlds and the structure of that export. Okay, time to actually code. Set up a project wherever your folder of articles is. This is my file structure, including the 2 Python files we will write. The 2 files we will write are in the same folder as the export given by Worldbuilding. Within this export, there is a folder of worlds with articles within those world folders. First, there are some libraries we will need. JSON to read JSON files, OS to access those files, and regex to extract information from those files. Next, we will define some data structures that will help us. Article nodes is a dictionary that holds all the important information about all the articles. Names dictionary is a mapping of article ID to article name, which we will use when displaying the graph. Ignored directories is an array that holds folders that we want to ignore during this analysis. The general strategy for this extraction is to enter directories recursively and to scan through the directories iteratively. If you don't know what this means, don't worry, hopefully the code makes it clearer. First, let's define the directory that holds the articles in relation to the location of the code. Next, let's define a function that will actually scan the articles. It has a name argument that is the path to the directory it is supposed to scan. We iterate through the objects in the directory, which we get by calling the scan directory function. We check if the object we have is another folder, in which case we filter out directories we specified to ignore, and then call the same function on those not filtered out. Calling a function inside of itself, like we are doing here, is called recursion. Otherwise, if the object we have is a JSON object that is not metadata, meaning it is an article, we open the file and load the data both as JSON and as plain text. From the JSON, which behaves just like a dictionary, we get the title of the article and its ID. We then scan the text of the article for links to other articles. Regex is very useful in this regard, but I will not explain regex in this video. Point is, we use it to identify where there is a link and what the linked article's ID is. After we have all this information, we store it in the articles node dictionary and the names dictionary. I actually forgot to save the names dictionary while writing this code, so you will see me add it later. With the function written, it is time to actually call the function. We call it on the directory we specified earlier, in which all the articles reside. Because of how often we'll need this information, it will be useful not to have to rerun this function every time we create a new algorithm. So we save the information of these 2 dictionaries into text files. This is just me adding the line of code I forgot to include earlier. Great, once we run this code, we will have all the information we need to construct a graph. If you aren't aware of what graphs are, here's a quick summary. A graph is made up of 2 things. A set of vertices we'll call V, and a set of edges we'll call E. Just for completeness, a set in math and computer science is an unordered collection of objects, so that no object can appear in the collection more than once. The set V is pretty simple, it just contains all the vertices. The set E, on the other hand, is more complex, being made up of ordered pairs of vertices, here called X and Y, which define edges of a graph. The first vertex in the pair is where the edge originates, and the second is where the edge terminates. This is what defines a directed graph versus an undirected graph. An undirected graph has sets to define edges instead of ordered pairs, and as just discussed, sets don't have an order. We will be using both directed and undirected graphs in the analysis to come in future videos. In our case, each article will be a node in the graph, and the links between articles will define the edges of the graph. For example, we have article 1, for which we create a node in our graph. Within article 1, there is a link to another article, article 2. This link means that there will be an edge from article 1 to article 2. Alright, back to the code. We make another file to hold our graph and our visualization. We import some useful libraries, networkx to make the graph, pyvis to display the graph. We import the two useful dictionaries that we saved to text files earlier by using the json.load function. Using networkx, we construct a directed graph as such. For each of the articles, we add a node with the article ID to the graph. Next, we iterate through each of the links in each of the articles, adding edges from the current article M to the linked article L. This basically concludes everything about making the graph, but let's clean up some edges that don't make any sense. Here we remove links from an article to itself, which gives us very little information. With the graph now created, we will use pyvis to display it. First, we set that all the nodes are labeled with article names instead of with article IDs. Next, we create a pyvis network of the size we want and with the colors we want, specifying that it is directed. Pyvis then takes the graph we created in networkx and converts it to something we can view. If you want to mess around with the physics engine of the graph, show the buttons that control physics. Then, we show the graph with the name that we want to save it as. The code is now done, so we can run it, which should bring up your browser with the HTML file we just created. Depending on the size and interconnectedness of your world, this might take a while to load. After it loads, you can see your graph. Depending on the size of your world, it might be a lot easier to glean useful information from this graph. For me, it just looks like a hairball or a bunch of spiders. Still, the graph does display some useful information. It shows articles that are not connected to any others, which articles are in the core of my world, and which are more in the periphery of my world. Just by looking at this graph, I can kinda tell where I need to add more information or more connections, and which articles I should suggest as gateways into my world for new readers. In the next few videos in this series, we will explore some sorting algorithms that try to make sense of this mess, as well as some algorithms that cluster or break down this mess into more manageable pieces. The goal is to have an algorithm that suggests a reading order so that I don't have to go through all of my articles and order them manually, because that's way too much work. If you made it this far in the video, thanks so much for watching. I hope it was useful or at least somewhat interesting to you. It sure was for me to make. There's some interesting considerations to be made with this sort of tool in Creative Works that I quickly wanted to discuss here for anyone that is interested. If this analysis and display gives me an idea for places where my world building is lacking or sparse, is that my idea? This question might be a bit nonsensical at the moment because of how basic the visualization is, but hopefully it becomes more interesting the more we explore ways that technology can be used to enhance creativity. Of course, there are many discussions at the moment about how artificial intelligence interacts with creativity, with the release of things like DALL-E 2, but there's also much more mundane artificial intelligence like autocomplete or things like that might also influence one's ideas while writing. What we're creating here could be seen in the same vein as that autocomplete, but at the current moment saying yes to this question is about the same as saying that realization is formed through the use of corkboard and pins and red string with the ideas of the corkboard, the pins and the string. So currently I think I cannot answer yes to that question.